The charge of an anion allows us to determine the number of electrons. We know that the number of protons for an atom of a given element never changes and is found on the periodic table as the atomic number. The charge of an ion is due to the unequal number of protons and electrons. To determine the number of electrons, we subtract the overall charge of the ion from the number of protons. Let's apply that mathematical formula. Determine the number of protons and electrons in the following ions: potassium, or capital K, charge of positive 1, and oxide, or capital O, charge of negative 2. Pause the video to get the answers. We need the number of protons, and potassium has an atomic number of 19, and it has 19 protons, and oxygen has an atomic number of 8, and thus has 8 protons. For the potassium cation, the number of electrons is 19 minus the charge of plus 1, which is 18 electrons. This makes sense since cations have more protons than electrons. For oxide, we subtract the charge of negative 2 from 8 to obtain 10 electrons. This also makes sense since anions have more electrons than protons. It is actually no coincidence that the number of electrons in those ions equals the number of electrons in the nearest noble gas. Oxide anion had 10 electrons like neon, and potassium cation had 18 electrons like argon. Main group atoms that are nonmetals will gain up to 3 electrons to obtain the same number of electrons as the nearest noble gas. And main group metals tend to lose electrons to obtain the same number of electrons as the nearest noble gas. Thus, there are a series of monoatomic ions that have the same number of electrons as noble gases. A series of ions that have the same number of electrons is known as isoelectronic. That means we will see main group monoatomic ions with 10, 18, 36, and 54 electrons.